Hi everybody, welcome to our energy practice test. And here are the answers. The first one just says diagram the system. Notice it says using our 7 types with arrows. So this one would diagram out as follows. It'd be radiant to electrical to mechanical. Notice though we did not say light, we said radiant. We did not say sound, we said mechanical. So it's important to use our 7 categories that we have. Next question. What do you notice about the bars in the graph regarding the energy going into the system and those representing the energy staying in the system and coming out of the system? Well, hopefully you're going to say that you recognize this bar is the same total height as these bars. Not only is this shown right there, but more importantly, we also know from the law of conservation of energy that we never create or destroy energy. What goes in always comes out, and we did that in amplify number 1. So that was the big idea in that particular one with the law of conservation of energy. Next, what is an energy what is a transformation of energy? Tell one place in this system where a transformation is taking place. Be specific about what's transforming into what and exactly where it is occurring. Well, the first one we just need to say a transformation of energy is when one type of energy turns into another. And we got this when we did balls of fury. We had motion energy turn into heat energy that burned the hole in the paper. And in the diagram up here, we have a couple of different transformations that we can say took place. Right here, as it says down here, we've got radiant energy being turned into electrical energy here. And you want to say radiant to electrical at the solar panel. Be specific. Here, we've got electrical to mechanical at the sound system. So you want to say what a transformation of energy is and give one specific place in the system, and you had a choice of 2 here where we have a transformation of energy. Next, the diagram below shows a pendulum that swings to the same height that it was released. Could this happen? And we can see that we have this where it's swinging to the same height. I'm not sure where it started, but both of these are the same height. And this one we covered in amplify number 2. Sorry, it took me a minute to find it. And it said some energy is always transformed into heat. And that's key and why we've never been able to make a perpetual motion machine. And that's the answer to this. The pendulum could not swing to the same height that was released because some of the pendulum's energy will be lost to heat as it swings.
All right, question number 5. What are 2 energies that we transform into electricity? We saw this in our making electricity. That electricity can be transformed from chemical and motion energy. And so those are our 2 types of energies that transform into electricity. Question number 6 was also from making electricity. What 3 things do we need for making electricity with a lemon? So we watched that video on the lemon battery, and the 3 things that we need are acid, zinc, and copper. And again, that then is our chemical reaction to make electricity. Question number 7, what is one advantage of using motion to transform into electricity versus using chemicals? This was in our electrical energy and our AC production labs here. Our big idea, each type of transformation to electrical energy has benefits and shortcomings, and the 3 main ways of making electricity are dams, burning coal, and motion. Sorry, couldn't read that. So one advantage
That's because it was my handwriting.
well, one advantage of using motion to transform into electricity is that we can make a lot of it. We have more motion available to make that electricity. And number 8, we transform energy into electricity with dams, wind turbines, solar panels, batteries, coal burning plants, and nuclear plants. Of these, list the 3 ways that make by far the most of the electricity that we transform. And we talked about that in the United States. We use dams, coal burning plants, and nuclear plants. And finally, number 9 asked you to draw a diagram of 2 magnets that will create a pulling force. Draw them so that they have no potential energy. And that is going to be from our lab, 2 strong magnets. In this case, we have to have our magnets with opposite poles. So we have a north and a south and a north and a south so that they pull together. And it also asked to have no potential energy. And so in order to have no potential energy, our magnets have to be stuck together. They're not in the process of pulling. They're already together, so there is no potential energy present.
Thanks for watching, everybody. Good luck on the test.